Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is Women in Science. And here to talk with me are two members from the Michigan Science Center here in Detroit. First, we have Angela Cavanagh.
Hi, Don. Thank you so much for inviting me. Really excited to be here on the show today.
Glad to have you. And Paulette Epstein.
Thanks so much for having us, Don.
You're both welcome, and I know, Paulette, this isn't your first trip to the rodeo.
No, no.
Glad to have you both. Now, I think it's kind of important that we do the show now because March is Women's History Month, so a perfect tie-in. So, Paulette, tell our audience a little bit about yourself.
Yeah, absolutely. So I am born and raised in Wisconsin, so little small town in the middle of nowhere farming community called Waterloo. And I loved the nighttime sky growing up. So I was able to go outside, take a look at the nighttime sky, and really get to know nature all around me. I went to school at the University of Wisconsin-Stevens Point, did a little bit of work at Texas A&M University down in Texas, College Station, Texas. And you know, I now work at the Michigan Science Center. I've been there for 10 years. I just celebrated my anniversary.
Oh my goodness, it's been that long.
It has been that long. And so I work at the Michigan Science Center. I'm the Director of Science Partnerships and Theaters, our staff astronomer, and in my free time, on top of all of that, I'm a NASA Solar System Ambassador. So.
Wow, great. And Angela, how about you?
So I actually grew up right in the Metro Detroit area. I'm from Troy, Michigan. My parents still live there. It's a lovely place. And I went to all-girls school growing up, but I remember very young, my brother was very into the zoo magazine books, and so that was sort of how I started to get interested in science, because I remember I would take them and read them, and I remember reading about Jane Goodall first, and it was so cool that this amazing woman was doing this research that no one had previously explored in the same way. And so, like I said, I went to all-girls school. And then I went to College of the Holy Cross, which is in Worcester, Massachusetts, and I studied physics. When I was doing physics, I also did research in supercooled atoms, which was really fun. I was doing some electrical engineering, as well as laser mirror optics, things like that, which was very interesting, but also did not feel like my calling. I was glad that I did it, but it was not the long-term fit. So I ended up going to grad school and studied elementary education, and then was working in a classroom for about 3 years. And then once COVID hit, things had really changed sort of the formal education setting, and so I came back home to Michigan and found Michigan Science Center. That was about 3.5 years ago, and we've been here ever since. And so I've held many positions, most recently public programs manager, but now I've recently stepped into the director of education position. So.
Great.
Yes.
Great. Now, Paulette, when you were growing up, what or who inspired you to what you're doing today?
Yeah, so I was really lucky. I was really interested in astronomy, and so and there aren't a ton of role models when it comes to women, popular women in astronomy. Mm-hmm. There's a few, and I learned about those kind of as I got into college and learned about Annie Jump Cannon, learned about Vera Rubin, etc. But growing up, I really had the opportunity to have close mentors to me. So when I was in school, especially high school, my physics teacher, Miss Sharon Brock, was a woman, and she also had red hair, and she was really an inspiration to me to really be interested in math and science. And then in college, my research advisors, both of them were women, and so I was really lucky to have that really close tie to mentors as I came up through school and into my career, but also my dad was a really great mentor because he encouraged me to do it. Mm-hmm. So not only did I have these role models and mentors that I worked with, but he told me, hey, you can do it, and it's okay that you're the only girl in the class. Mm-hmm.
Well, it's good that you did have the female mentors. Mm-hmm. Going back 50 years or so, that probably wasn't the case, but mm-hmm. fortunately things are changing, and you had that opportunity.
Mm-hmm. Yep.
So Angela, who or what inspired you?
Yeah, so I also had many great teachers, like Paulette did. I didn't quite have a connection with a mentor in the same type of way, but like I said, I went to all-girls school, and so it was very interesting to just like be inspired by all the very intelligent young women who were around me, and you know, I was always chasing the girls who were at the top of the class, and you know, wasn't too far behind. But it was really great to just support each other in that way, which I think is not a unique experience to me at all. But it's really important to, you know, feel lifted up by the people around you. And then when I went to college, I participated in a really interesting program called X-Chrome, and basically it paired college students with high school girls who were interested in science. They weren't, you know, they were in high school, so they hadn't chosen their career paths or anything yet, but we sort of worked with them about, you know, this is what collegiate courses are like and things like that. And I remember my mentee was way cooler than I was, and she had like traveled the world, and she, you know, had already done medical research and all these things, and I was like, wow, you're like teaching me. And so what that sort of taught me is that there is inspiration that comes from all around, people of all ages. And then I remember when I was a teacher, I was interested in, you know, emphasizing women in science, because I was teaching math and science to middle schoolers. I was interested in teaching women in science just as much as, you know, the men were present in the textbooks. And again, it was really interesting how the students sort of picked up on those things and how they asked questions about, you know, well, who is this person, and well, who did this thing? I was definitely like a why kid myself, of like asking lots of questions, which I think Paulette can probably relate to, and that's why we got into physics in the first place, which was really wonderful. And then, you know, other teachers around me were like, well, have you heard of this person? And one of the people that I remember really specifically came up was Henrietta Lacks. And her story is so interesting about, like, she wasn't even a scientist. She was a mother, and all of a sudden her story came out, and then I think they made a movie about her life experience and the HeLa cells. And these were things that I didn't know about, and how impactful they have been on medical advances and all that. So I really try, even still, to read lots of books about women in STEM and just inspiring women in general, because I think it's important, and you're always learning, you know, there's no cap.
That's true. I mean, there's a lot of women out there and their stories, many of which just don't get told. And I know I had one experience when I was still working at the Science Center doing outreach. The American Association of University Women would have a program, and they would have high school girls there. Are they still doing that? Do you know? Has the Science Center been involved with that?
We've been involved in a lot of women-focused programs. So we have our 4th through 8th grade girl program, the STEMinista project. So we work with middle school girls, because one of the things that we find is that the interest in STEM really drops off at that age group. Like, it becomes so, like, in early elementary, like, girls outperform the boys in science and math. But then it becomes uncool, and so the girls kind of just like toss it aside so that they can be cool with their other girlfriends. And I mean, that didn't happen to me. I was just uncool. But so
And we're glad you were, by the way.
yeah.
I think you're cool.
That program really encourages middle school girls to continue with that. So we do a lot of those girl focused programs, and we have continued to do our STEMinista project, which also has started to pair those middle school girls with mentors as well. So I was a mentor 2 years ago. And it was really great to work with them. And you know, Angela, you mentioned that you had these programs like in college and stuff like that, and like those. I'm not that much older than you, and they didn't exist when I was in school. Like, there's a lot of programs out there for middle school girls, for girls in general, that just did not exist before, and they're so important and impactful that, like, who knows what would have happened had I actually had, like, other than just the 1 or 2 teachers going, it's okay that you're uncool and sitting in the back or sitting in the front of the room, raising your hand at every turn. If I had had something like that when I was younger, it would have been just amazing.
No doubt, no doubt. Now, we talked a little bit about what you do now, but prior to coming to my side, Paulette, what was some of your work experience or research?
Yeah, so my background is in astrophysics. I did Many different types of research. So I started, my first research round was at Kitt Peak National Observatory, and I did 10 total nights of observing, 5 nights over 2 years in a row, and I studied an asteroid named Tim Hunter and determined the light curve. So determining the light curve of an asteroid allows you to know the shape, what it's made out of, the reflectivity, all the size, all of those mass, all of those different things. So that was sort of my first delve into research, and that was actually my freshman year of college. Like my freshman year, I marched into my professor's office and I was like, I want to do research, and she was like, we'll see about that. And second semester, she was like, hey, you want to come with me? Yeah, let's do it. And then my other research, I also did a little bit of work at Texas A&M in dark matter. So I was helping to build dark matter detectors with the cryogenic dark matter search. And then the other research that I did was using the Sloan Digital Sky Survey data to try to determine the evolution of galaxies. So we looked specifically at spiral galaxies that were face-on, so instead of edge-on, they were face-on, so we could see them. And we studied and pulled apart the different parts of the light. And we took a look at how they changed over time. So the ones that were really close to us versus the ones that were further away. How were they different? How were they similar? So how did they evolve over time? So I did a lot of research in school. And I will say, like, the thing that always brought me back to my love was the planetarium. So I started at my university planetarium in school. I went and did an internship in Davie, Florida at a planetarium there. I worked at the Adler Planetarium in Chicago for a while. And then I came to the Michigan Science Center to run the planetarium, and not just run the planet, and then I started taking over the world. So the theaters, yeah. So I run all of their theaters now, not just the planetarium. But the content that goes through our planetarium, I still get to write it, I still get to program it, and I really, really enjoy the communication aspect of things, because one thing that I learned when I was going to research conferences and stuff like that was scientists are not always the best communicators. So even people that were in the same research as me couldn't communicate their research to me in the same little pod of research. And so I was like, man, I got to go into science communication, and the planetarium was just kind of my way in.
Great. That's awesome. Angela.
Big question. So I did not do as much research as Paulette. I think I spent like 3 semesters doing research in the summer. But like I said, I was working on a project that had to do with very, very cold atoms, like microkelvin. And so my piece of the project was working on the laser's feedback loop. And so, like I said, it was some electrical engineering, and if the frequency got off or if it got misaligned, the little circuit box that I built would kick it back into place, because you need it to be really precise so that those atoms can be really cold. And then we were dropping them and looking at their scatter patterns, which was also really interesting, but a different side of the project. And I just really enjoyed the sort of circuitry side of things, a lot of soldering as well. I've realized that I enjoy soldering, and also like the building and then testing of it. There had been an iteration before, but I was sort of coming in with 2.0. So that was really interesting, but my sort of interest in college was more on sort of the education side of things. And so I volunteered at a lot of high schools, middle schools, in their specifically math and science sort of areas, helping those kids if they had questions with their homework, whatever that might be. And then I was also a tutor for like the introductory physics courses, which I loved, because intro physics is the best. It's just all toys that you get to play with, and everything makes a lot of sense, and you can negate gravity and air resistance all the time, which is awesome. And then you get to the higher courses, and all of a sudden it matters. But I just really enjoyed always sort of the explaining it and showing folks how cool it is, because people are afraid of physics because it's very math intensive and it takes a lot of logic and reasoning. But I think once you sort of get past that fear, and I know Paulette is laughing because she feels the same, once you get past that, you're like, whoa, like I can explain why things work in the world. So that was what I really enjoyed about sort of the tutoring side of things, and then why I wanted to go into the classroom teaching. And then why I came to informal education, when now I can work with very little kids in all different domains of science, all the way to adults on our adult nights, and show them all types of cool science stuff that they forgot that they're still able to enjoy.
Great.
It's so funny that you mention that in the lower level physics you ignore gravity and friction and all of that. My favorite thing that a professor ever said was in our advanced mechanics class. We walk in and he just looks at us and he goes, "Everything you were taught in physics so far was wrong."
It all matters.
It all matters. And then the upper level physics classes, you start to add those things in, and it got harder from there.
Yeah. Just as fun, though.
Yes, yes.
For sure. We're going to take a quick break. If you have a question, please send us an email. The address you'll see down at the bottom of your screen. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is KM3NET. KM3NET is the Cubic Kilometer Neutrino Telescope. The project started in 2012. Its second phase of construction ran from 2017 to 2024. It's being built in the Mediterranean Sea near the Italian island Sicily and near Toulon, France. The sensors are light detecting glass spheres anchored to the seafloor that detect Cherenkov light from high-energy electrically charged particles such as muons. Muons are produced when cosmic rays hit Earth air molecules, but also sometimes when a cosmic neutrino hits. A neutrino event in February 2023 was estimated at 120 peta-electron volts of energy. This is the most energetic neutrino on record, and by a factor of 20. The analysis took place in 2024, and researchers have taken additional time to be sure what it was. The often higher energy cosmic ray events, like the one dubbed the oh my god particle, was 320,000 peta-electron volts. That's a record in a completely different category. The observatory construction continues, so stay tuned. And that's the term of the month, KM3NET. Back to you, Don.
Thanks, Stephen, and welcome back. I'm here with my two guests, Angela Cavanagh from the Michigan Science Center, and also Paulette Epstein, also from the Michigan Science Center. So, in this segment, we're going to talk about a topic that I'm sure you have both encountered in your careers, and that's the challenges for women in STEM. So who wants to go first?
Yeah, so we mentioned before about our STEMinista project, so 4th through 8th grade girls, trying to encourage them to stay in STEM. And I know I experienced this a lot when I was a kid, the bullying from being interested in it. And it's less of an issue now. It's a little more hip to be scientific, if hip is still an okay word to say. But you know, that is a huge challenge that girls have to overcome just at a really, really young age. And then as we continue in our careers, it can be really tricky. I know, so I mentioned I did all of this research. The first time I ever had a male mentor or a male research advisor, he didn't credit me for my work. He didn't credit me for my work. He didn't write a letter of recommendation that he said he was going to write. And so that was really tricky to move forward through my career. Luckily, I took a pivot and went into science communication and education, but it was really frustrating and a huge thing that I really had to overcome that doesn't necessarily happen to men when they come up through the field, and it's something that happens a lot to women. They have a much harder time becoming published. They have a much harder time getting recognized for their work, and it's getting better, but we still, especially in physics, we still have a really long way to go.
A lot of this is, you think, just built-in societal bias?
Yeah, I think that's a big part of it, and I think and I think it's just the way things have been for a really long time, and it's hard to change those kinds of ideas. So I know we're working through it, and we're encouraging the next generation to overcome those when they get to that place. But like I said, between Angela and myself, we're not that much different in age. It's maybe 5 years or so. And like just when she was in college and when I was in college, things were very, very different.
Okay, so there has been progress made, right?
Yeah, I will say, I mentioned that I went to an all-girls school all the way through high school, and so there wasn't any competition, right? I was surrounded by other young women. Most of my teachers were also women. There were a handful of men sprinkled in as well. But I never experienced that until I went to college. And then, physics departments tend to be small in general, especially at a liberal arts school. And then with that really small community, the number of women is even smaller. And so I know I internalized a lot of like imposter syndrome, like, am I really supposed to be here kind of a thing. Luckily, in college, I did have really awesome mentors. There was one woman professor in the department, and she was tough. I just remember, like, she taught the quantum classes, and she was tough, but she was also brilliant. And so I just remember being like, all right, well, I want to impress her, and I want to put my best self forward. Obviously, so I do a good job, but also so I show her, like, this is you're putting yourself out there for women like me who want to pursue the field as well. So, yeah, I would say I luckily didn't have any sort of direct challenges like Paulette's were with the research publishing and things like that. But sometimes just being in a room and feeling like you're worthy of having your voice heard when maybe you're the only woman there can be really challenging. It can be really scary, especially if it's a group of people you don't know.
Exactly.
Yeah, and one, like I mentioned, like I didn't really learn about these female astronomers until I was in college, like Annie Jump Cannon, Vera Rubin, and Carolyn Herschel, for example. And a lot of the...
she goes back several hundred years.
She goes back several hundred years, but her research and her contributions to science weren't recognized until relatively recently.
Everybody looked at her brother.
Everybody looked at her brother, exactly. And so we're really coming a long way by recognizing the people in the past who've done these amazing things in science, as we also recognize the people who are currently doing amazing things in science. So really recognizing the historical figures, going back and writing our history, rewriting our history to acknowledge the people like Carolyn Herschel who really did put a lot into the things that she discovered.
Right. Well, even in the movie Hidden Figures, the women computers who did the hard work for the space program.
Yeah, they did a lot of the math, and they were a big part of why we got to the moon and why we came back. And even after computers, like actual computers, became a thing, they went back to Katherine Johnson and were like, hey, I don't trust the numbers that came out of this IBM. Can you please rerun them?
And sort of in the more modern age, I think it's really interesting with all the social media and things like that, the way that women in STEV have become influential in a very different sort of public light. So I know I follow several female astronauts who talk about sort of their research and how they were chosen, and they're not only astronauts, but they also are sometimes models or mothers or all these things that it's like, well, how can you have it all? That was always a question of like, well, women should be at home doing this particular thing, but like, no, you can kind of do all the things, you can accomplish all those dreams, and there are people who will support you. And I think it's really interesting that they say that like these are really big advances for women, but it's like, no, women have always been this smart, and women have always been this, eager to do these things.
Just being recognized for it.
Exactly. And so to finally get out there and do it, and to be able to watch women do it in real time is so amazing. So.
Yeah. So like, for example, we had a beauty queen at the Science Center, Miss United States, and she's a scientist. Like, she's a beauty queen, but she's a scientist. And man, I saw her from our office area, from like all the way across the museum, and her crown was sparkling. I went and got myself a tiara.
You can wear a tiara and a lab coat simultaneously.
You can.
There you go.
can absolutely do that, yeah.
Everything that women have done in the last 50 years gives a whole new definition of the term women's work.
It's true.
Absolutely.
I'd like to thank both of my guests for being here to talk about the subject of STEM and their experiences in it. Please visit our club website. The address is down there at the bottom of your screen. And coming up to finish out the show is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for March 2025? We have the equinox on the 20th of March. That's the spring equinox in the northern hemisphere and the autumnal equinox in the southern hemisphere. Then we have the moons. The first quarter moon is on the 6th, the full moon is on the 14th, the third quarter is on the 22nd, and the new moon is on the 29th. The moon images are credited to J. Starble. Thank you. Then on the 1st of we have Saturn, Mercury, Neptune, Venus, and Jupiter shown at sunset. Saturn is in Aquarius and sets half an hour after sunset, but at the end of the month it rises half an hour before sunrise. And that's because Saturn has superior conjunction behind the Sun from us on March 12th. Then we have Mercury goes from Pisces, is in Pisces all month. It sets half an hour after sunset to rises half an hour before sunrise. Inferior conjunction, that's Mercury between us and the Sun, is on the 24th. Then we have Neptune in Pisces. It has superior conjunction on March 19th. It's not a great month for Neptune. And then Venus is also in Pisces and sets an hour after sunset to rising an hour before sunrise. It's actually better at the beginning of the month. And on March 22nd, it also has inferior conjunction. Then we have Uranus, Jupiter, and Mars on the 31st at an hour after sunset. Jupiter is in Taurus and sets from 5 hours to 6 hours before sunrise. Mars is in Gemini and sets from 2 hours before sunrise to 3 after before sunrise. So it's a little better at the end of the month. And then Uranus goes from Aries to Taurus and sets from about 6.5 hours before sunrise to 8 hours before sunrise. So again, it's a little better at the end of the month. And that's what's up in the night sky for March 2025. Remember, we don't charge money for this show, but we may tax your brain.